Imagine a volcano erupting with such force that it blasts millions of tons of ash and rock into the atmosphere. The sky darkens and the ground trembles under the immense power of the eruption. This is the terrifying power of a supervolcano, a geological giant capable of altering the course of history. Unlike typical cone-shaped volcanoes, supervolcanoes are massive, hidden underground, and capable of eruptions that dwarf any witnessed in human history. They form vast calderas, often tens of kilometers across. Supervolcanoes don't have a single universally agreed-upon definition. Their immense size and potential for destruction make them a subject of intense study and debate among scientists. However, scientists generally classify them as volcanic systems capable of producing eruptions with a volcanic explosivity index, or VI, of 8, the highest rating on the index. This classification underscores their potential for catastrophic impact. These eruptions eject an unimaginable volume of material, more than 1,000 cubic kilometers, with devastating global consequences. The ash and gases released can alter climate patterns and affect life across the planet. The sheer size and power of supervolcanoes make them a unique and terrifying geological phenomenon. Their potential to cause widespread destruction is unparalleled. Their eruptions are unlike anything humans have ever witnessed, and their potential impact on our planet is a sobering reminder of the immense forces at work within the Earth. Understanding these forces is crucial for our survival and preparedness. Supervolcanoes are not evenly distributed across the globe. They tend to form in areas where the Earth's tectonic plates meet and magma can rise from the mantle. One of the most well-known supervolcanoes is located in Yellowstone National Park in the United States. Another significant supervolcano lies beneath Lake Toba in Indonesia. This sleeping giant is a stark reminder of the devastating power of super-eruptions. Other notable locations include the Long Valley caldera in California and the Taupo volcanic zone in New Zealand. These locations are closely monitored by scientists for any signs of activity. Understanding the behavior of these geological giants is crucial for preparing for the possibility of a future super-eruption. Super-eruptions are thankfully rare events. The last known super-eruption, the Orowanui eruption of New Zealand's Taupo volcano, occurred roughly 26,500 years ago. However, the potential consequences of such an event are so catastrophic that they demand our attention. One of the most immediate threats from a super-eruption is the sheer scale of the explosion. The eruption column would reach high into the atmosphere, potentially reaching heights of tens of kilometers. This would lead to widespread ashfall, blanketing the surrounding landscape in a thick layer of volcanic debris. This ashfall would have devastating consequences for agriculture, transportation, and human health, potentially impacting billions of people. The sheer volume of material ejected into the atmosphere could also trigger a volcanic winter, leading to global cooling and widespread famine. The impact of a super-eruption would not be limited to the immediate vicinity of the volcano. The massive injection of ash and sulfur dioxide into the stratosphere would have far-reaching global consequences, impacting climate, ecosystems, and human civilization for years to come. The sulfur dioxide would react with water vapor in the atmosphere, forming sulfate aerosols. These aerosols would reflect sunlight back into space, leading to a cooling effect on the Earth's surface. This volcanic winter could last for several years, disrupting agricultural cycles, leading to widespread crop failures and potentially causing mass starvation. The environmental and societal impacts of such an event are difficult to comprehend fully. It would be a global catastrophe, testing the resilience of our infrastructure, our food systems, and our ability to cooperate on an international scale. Learning from the past, the Toba eruption. To understand the potential impact of a super-eruption, scientists look to the past, studying ancient events that shaped our planet. Around 74,000 years ago, the Toba supervolcano in Indonesia erupted with cataclysmic force, altering the course of history. This eruption, the largest known in the past 2 million years, ejected an estimated 2,800 cubic kilometers, or 670 cubic miles of material into the atmosphere, creating a global catastrophe. The Toba eruption is believed to have plunged the Earth into a volcanic winter lasting several years, drastically affecting the climate and ecosystems. Some scientists believe this event may have even caused a genetic bottleneck in human evolution, reducing the human population to a few thousand individuals, a theory that continues to be explored. While the exact consequences of the Toba eruption are still debated, it serves as a stark reminder of the potential destructive power of supervolcanoes and the need to understand and prepare for such events, ensuring we are better equipped to face future geological threats. Given the potential threat posed by supervolcanoes, scientists are constantly monitoring these geological giants for any signs of unrest. Using a variety of techniques, they track ground deformation, earthquake activity, gas emissions, and other indicators of magmatic movement. Seismometers are used to detect even the slightest tremors within the Earth's crust, which could indicate the movement of magma deep underground. GPS stations measure minute changes in ground elevation, signaling potential pressure changes within the magma chamber. By carefully analyzing this data, scientists hope to detect any warning signs of an impending eruption, giving us as much time as possible to prepare for the potential consequences. While scientists are making progress in monitoring supervolcanoes, predicting the exact timing of a super eruption remains a significant challenge. The processes that lead to these massive eruptions are complex and not fully understood. Current monitoring techniques can provide valuable insights into the state of a supervolcano and help identify periods of increased unrest. However, predicting the exact timing and magnitude of an eruption with certainty is not yet possible. Research into supervolcano behavior is ongoing, and scientists are developing new technologies and models to improve our understanding and predictive capabilities. However, the unpredictable nature of these geological giants means that we must be prepared for the possibility of a super eruption at any time. Surviving a supereruption would be a monumental challenge, requiring a combination of individual preparedness, community resilience, and global cooperation. While the immediate impact of an eruption would be devastating, there are steps we can take to increase our chances of survival. Creating a network of hardened shelters stocked with essential supplies such as food, water, and medical equipment would be crucial. Developing resilient food production systems that are less reliant on traditional agriculture would be essential for long-term survival. International collaboration would be paramount. Sharing resources, coordinating evacuation efforts, and providing humanitarian aid to affected regions would be critical for mitigating the global impact of a super eruption. Supervolcanoes are a stark reminder of the immense power of nature and the vulnerability of human civilization. These colossal forces of nature have the potential to reshape entire continents and alter the course of human history in an instant. While the likelihood of a super eruption in our lifetime is relatively low, the potential consequences are so catastrophic that we cannot afford to ignore the threat. The ash clouds, pyroclastic flows, and climatic changes could have far-reaching impacts on global agriculture, infrastructure, and human health. Investing in scientific research, developing robust monitoring systems, and creating comprehensive disaster preparedness plans are crucial for mitigating the risks posed by these geological giants. These efforts help us understand the warning signs and potential triggers of super eruptions, allowing for timely evacuations and emergency responses. Raising public awareness about the threat of super eruptions and promoting individual preparedness measures are also essential. Educating communities on how to respond during an eruption can save lives and reduce the overall impact of such a disaster. The future of our species may well depend on our ability to recognize the threat of supervolcanoes, prepare for the worst, and work together to overcome the challenges they pose. Collaboration between scientists, governments, and communities is key to building resilience. By embracing a culture of preparedness and resilience, we can increase our chances of weathering the storm and ensuring the survival of humanity. Together, we can build a safer, more resilient future for